Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, obtaining metals. So what technique do we use to extract each of these different metals? Now, on my left is my reactivity series, and that's important because it's going to inform which technique we use depending on which metal it is we're trying to extract. And it might be no surprise to you that the easiest metals here to separate are the ones that are lowest on my reactivity series, so silver and gold. Because they're not very reactive, you can actually find them as pure uncombined elements in nature. So all you have to do is physically separate them from their surroundings, such as panning for gold. But gold and silver are the only ones. Once we move above that in our reactivity series, you're not going to find them as pure uncombined elements. So our next three that come together in a group, copper, iron, and zinc, these three, we can use a displacement reaction with carbon to extract the metal. So because these three are actually below carbon in our reactivity series, that means that carbon will be able to displace them. So anything above in the reactivity series, you won't be able to use this method for. And basically, what does it entail? Well, let's imagine you had some copper oxide and you wanted to get copper. Well, you add your carbon to the copper oxide and you end up with carbon dioxide and copper. So it displaces the metal from its metal oxide, for example. Okay, and then higher up on my reactivity series, you can't use carbon. It's not reactive enough to displace them. You would have to use molten electrolysis. We went through electrolysis in an earlier topic, but the problem with using molten electrolysis, if you don't need to, is that actually you need a lot of energy required to do this. Okay, let's have a look at our displacement equation. So give the overall equation when carbon is used to reduce zinc to oxide. So the products that I'm going to get from this are CO2 as a product, and also the metal that I wanted to extract, zinc. And so I can write those products on the right-hand side, CO2 plus zinc. Now, what is the formula for my zinc oxide? Well, it's zinc 2 oxide, which means that my zinc ions have a charge of +2, and oxygen is in group 6, which means that the oxide ions will have a charge of -2, and therefore both of those charges are balanced, so I can just write ZNO as my zinc oxide formula. So zinc oxide plus C for carbon gives me carbon dioxide and zinc, but now I notice that this isn't balanced, so I'm not finished yet. So first I need to balance the oxygens. So on my right-hand side, there's 2 oxygens from the carbon dioxide, but on my left-hand side, there's only 1 oxygen from the zinc oxide. So put a big 2 in front of that zinc oxide. Now I've got 2 oxygens on both sides. But now I need to balance the zincs, because by putting that 2 in front of the zinc oxide, not only have I now got 2 oxygens on the left-hand side, I have 2 zinc on the left-hand side. So add a 2 in front of zinc on my right-hand side as well, and then just check that everything else is balanced. 1 carbon, 1 carbon, we're all good, so that's my final equation. Okay, let's look at some questions about life cycle assessment. So what do we not need to worry about when creating an LCA, and what are the 4 stages of LCAs? So the important thing to not get the misconception of is that we are assessing how much money it's going to use to make this particular product. We're not interested in money at all. When we're doing a life cycle assessment, our only goal is to consider the impacts on the environment. And then what are the 4 stages of the life cycle assessment? Well, let's look at the first one. So you need to know that the first one is about extracting the raw materials that you need for this product. And the reason that's important environmentally is because you could do some damage to natural environments if you were, for example, having to mine the metals that you needed for that particular product, or if you're having to use molten electrolysis, for example. like we mentioned in the previous slides, it takes a lot of energy in order to extract a metal like that. And you need to have transferred that energy from somewhere, so that will often involve burning fossil fuels in order to create that energy so that you can do your molten electrolysis. And we know that fossil fuels are not only a finite resource, but also they lead to climate change because they release CO2 into the atmosphere. Next stage is the manufacturing and the packaging of the product. And again, when you're trying to therefore make these products, you can also have some environmental impacts, such as, again, maybe having to burn fossil fuels so that you could have the energy, for example, to melt metals that need to be cast into certain shapes. So something like that. Next stage is using or upkeep of the product. So sometimes you might have to use extra materials in order to keep the product up. So the example in the notes is maybe you have like a bicycle chain, and one of the materials that you need to keep that product going is oil to use as a lubricant for your bicycle chain. And then if you're using oil as a lubricant, where's the oil coming from? You might use crude oil. So again, it's a finite resource that you're using up. And then finally here, disposing or recycling of the product. Yes. So maybe you're using landfill sites, so that obviously takes up a lot of space, or you could also be disposing of things by burning them, and that again will release pollutants into the air. Metals can be quite good because you can actually melt them down and recycle metals, but that process takes energy as well to do. So that's the final part of this life cycle assessment for a particular product.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Again, I think I warned you in the earlier topics, but remember, you need to know your reactivity series. It makes this a whole lot easier to know how you can extract these different metals. If you don't understand displacement reactions, then reduction by carbon might be tricky. So again, these equations are covered more detail in a later topic, so make sure to check those out. And then to remember that there are these links between the topics that could help you. When you're considering recycling environmental impacts of different processes, you can use your own intuition, look at the individual process, and you think through in your head, what do you think the environmental impacts of those things are going to be? Usually we tend to think about how much energy that process is going to use and where you're getting that energy from. So if you're going to have to burn, for example, fossil fuels or use a finite resource to get that energy, then that's going to be a problem, and it's going to release harmful gases into the atmosphere as well.